So now we've reviewed how to translate from one coordinate system to another if those two coordinate systems are rotated relative to one another. There's an even easier case that will be of relevance to us, which is when we are looking at coordinate systems that differ by a translation, where you slide one coordinate system relative to another. So let me just do that example quickly for completeness here. So again, let me set up my little system, set up my coordinate axes. Here's axis number 1, the y, axis number 2, say the x. And now the new system that I want to talk about just amounts, in essence, to moving the coordinate grid over, say, from the right to the left or from the left to the right. So let me just overlay that so that we can see it. And imagine that we're told that the amount by which the coordinates have moved over, let's say this amount, this distance here, say, is equal to a. Now, what is the way of translating from one coordinate system to another? Well, it's immediate. So if this is the xy system as before, this is the x prime y prime system as before. And let's imagine that we have some point P, I don't know, put it right over here. If P in the blue system, the xy system, has coordinates, let's say they're x naught, y naught, what will the coordinates of that point, what will those coordinates be in the red system? Well, if we have slid the red system over to the right by an amount a, that means the coordinates of this point x naught will be diminished by that amount because the coordinate system has moved under it, if you will. What about in the y direction? Well, we haven't done anything there at all, so that guy remains unchanged. So that's a nice, really simple dictionary that allows us to go between the two coordinate systems if a translation is involved. Now, you know that we sometimes like to get a little bit fancy when we're talking about physics and coordinates, and indeed what we can do is consider where we do the general case, where you both translate and rotate at the same time. It's not hard to work out. I'm not going to do the mathematics for you here, but it just is a combination of what we've already discussed. Instead, I'm going to let you play with it, again, by fiddling with some of these demonstrations. So let's take a look over here. So this is a case which will first just have the translation. So that's real simple. That's what we just described. Choose a point at will, slide the coordinate system back and forth, and make sure, it's simple, but make sure you understand how it is that these coordinates are changing in the translated system. But if we look at another example where we put both of those effects together, then it's a little bit harder just to eyeball. So now imagine that you choose the coordinates of a point. Let's put it over there. And now let's both slide the new coordinate system but also rotate it. And doing that, it's a somewhat more complicated mathematical dictionary. It's just a combination of the two effects that we've already been talking about. But again, it gives you at least a more intuitive feel for how it is that change of coordinates looks numerically when you look at some explicit example where you've got control of both the angle and the displacement. Okay, that's all that I really want to talk about on the issue of coordinates for space. The next thing that we are going to turn to is our real interest, right? This is stuff that's old hat to most of you, but our real interest is to take these ideas and apply them to time.